Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next type of miscellaneous problem on beta and gamma function. So this is our question. Integration of this is equivalent to 1 by 4 beta of n by 2 comma n by 2. Hence evaluate this integration. So we have to first prove this term, and by using this proof we have to solve this. So now if you see, we have the limits of integration from 0 to infinity. So we have the beta function as integration of 0 to infinity x raised to m minus 1 upon 1 plus x the whole raised to m plus n into dx. So this is the basic representation of beta function when we have limits from 0 to infinity. So in the denominator we have 1 plus x, that is 1 plus some variable, but here we have e raised to x term. So we put e raised to x equal to t, then x will be log of t. So when we put x equal to log of t, our limits of integration will also get changed. So here it is initial variable and here it is new variable. When we put x equal to 0 here, we get t equal to e raised to 0. So anything raised to 0 is nothing but 1. So we get t equal to 1. But we do not want t equal to 1. We want the limits from 0 to infinity only. So to sustain this limit, there is one property, that is some basic concepts we are going to use in this equation and in this problem, and you have to analyze such things in exams. We do not want to change this limit, so we are not going to do this substitution. We are going to do something. So we know that when f of x is equivalent to f of minus x, then it is called as even function. We all know this. When f of x is equivalent to minus of f of x, then it is called as odd function. And we have the properties of even and odd function in integration, that is when the limits are from minus a to a into some function of x into dx is equivalent to 2 times integration of 0 to a f of x dx when it is an even function. When f of x is even function, this limit can be represented as 2 times 0 to f of x dx. When it is an odd function, it is equal to 0. So now what we are going to do, we are going to check whether this is an odd function or any even function. So when we replace x by minus x, we get dx upon e raised to minus x. Here we are replacing x by minus x plus. When we replace here x by minus x, so minus minus will become plus, so it will be e raised to x the whole raised to n. So if you see, this term and this terms are exactly matching, that means f of x is equal to minus of x. This function is even function. So for even function, integration minus a to a, in our case it is from 0 to infinity, is equal to f of x dx. So we are going to use this limit. Why we are using this? Just see. So here we have integration of f of x. What is f of x? F of x is this term, that is e raised to x plus e raised to minus x the whole raised to n into dx, equivalent to 2 times this 2. So I am taking 2 here, so it will be half. Integration of 0 to upper limit is infinity, into f of x, that is this term, the whole raised to n into dx. And here we write upper limit, that is infinity, and minus of upper limit, so minus infinity. So what we conclude from here, if you see, this term is exactly matching with this term. So we can write this term equivalent to this term. So this is our new integration, which is I equal to half integration of minus infinity to infinity 1 upon e raised to x plus e raised to minus x the whole raised to n into dx. We can write this e raised to minus x as 1 upon e raised to x, and we cross multiply, then we get half integration of minus infinity to infinity e raised to nx. This is the whole raised to n. So when in the denominator, when we cross multiply, here it will be e raised to 2x upon e raised to x the whole raised to n. So when it goes in the numerator, it will be e raised to nx upon e raised to 2x plus 1 the whole raised to n into dx. So this is now our new integration. So now if we put e raised to x equal to t, our limits of integration will be from 0 to infinity. So our new integration is integration of minus infinity to infinity e raised to nx upon e raised to 2x plus 1 the whole raised to n into dx. So we have to make our integration in this format, that is integration of 0 to infinity x raised to m minus 1 upon 1 plus x the whole raised to m plus n into dx. So we have to make in this format. So we want in the denominator 1 plus x term, so we put e raised to 2x equal to some other variable t. Then 2x will be log of t and x will be log of t upon 2. So now we are changing the variable, our limits of integration will also get changed. The initial variable is x and the new variable is t. X is going from minus infinity to infinity. When we put x equal to minus infinity in this equation, we get e raised to minus infinity equal to t, which is nothing but t equal to 1 upon e raised to infinity. E raised to infinity is infinity, so 1 upon infinity. So t will be 1 upon infinity, which is 0. So now if you see, earlier we got our limit as 1, now it has changed to 0 by doing this thing.